X is the number of days, which we don't know, okay? What is Y? Y is the total number of trees in the forest. Okay? So we have to establish that. So if we take the slope, the number of trees planted per day, times X, the number of days, okay? And we add on B. What is B? Well, okay, B is called the y-intercept, okay? It could also be known as the base if you're talking about pay, your base pay. Okay, that's a good way to remember it. But it's the amount you start out with, okay? Before the days started ticking, when X is 0, when no days have gone by, how much did he start out with? How many trees were there? Well, that's our B. That's the amount you start out with, okay? So if we take the amount we start out with and we multiply 17 times the number of days, that will give us the total number of trees in the forest, okay? All right, but guess what? Oh, the formula is not complete because we don't know what B is. What a bummer. So B is a bummer, we could say, okay? I wish I knew what B was. How can we figure out what B is? Well, hey, wait a minute. Didn't we have an X and Y coordinate? Didn't we say that when X is 7, Y is 369? Yeah, we did say that. So look, when X is 7, here's Y. We could use that X and that Y to get rid of these variables. Then we'd be left with just B, and we could solve for B. Why don't we do that, okay? So let's pop in 369 for Y, okay, equals 17 times X is 7, here's 7, plus B. There we go. Now if we could just solve this equation for B, we're in business. We have the whole formula complete. Okay? Once again, I'm going to grab my calculator. 17 times 7, okay? 17 times 7 equals 119. Okay? So we have 369 equals 119 plus B. Okay? How do we solve for this now? We want to isolate B. Isolate. Subtract 119 from both sides. Okay? So what are we left with? We are left with B equals 369 minus 119. 9 minus 9 is 0. 6 minus 1 is 5. 3 minus 1 is 2. B equals 250. I love it. I love it. So we can just finish this formula, right? So here's our formula. Here's our function. Y equals 17x plus 250. We used slope to get the formula. Now that we have the formula, life is just a lot rosier, isn't it? Okay? So, hope this isn't too low. Let me just check if that's too low. So just make sure you see the... Yeah, oh, it's perfect. Wow. Okay. So here's our formula. Very happy about this. Let's use it to answer these questions now, okay? I'm going to just hold the camera while we answer the questions. How many trees were in Rupert's Magic Forest to begin with? Well, we said that's the B value. That's the B value. And the B value, if you look down here, boom, 250. See? B, boom, 250. So the answer is 250. Thank you. Hello. Okay? Second question. How many trees did Rupert plant each day? Well, that's the rate, right? That's the rate. Rate is also the slope. Where does the slope go? That's the M. Okay? That's the M, and the Y equals mx plus b. We figured that out early on. M17, boom! That's the slope, that's the rate. He was planting 17 trees a day. 17 per day. That's our answer for that one. Thank you, hello. We're good, we're good. Now here's the question. How many trees will the forest have after 30 days? Okay, so the number of days we said was represented by the X value, okay? So the X value is the number of days. So we want to plug in a 30 there, right? So we have Y equals 17 times 30 plus 250. So 17 times 30, I'm going to use my calculator again, okay? So here it goes. 17 times 30 equals 510. So Y equals 510 plus 250, okay? So we can just write that out, 250 plus 510, okay? Don't be afraid to write out something on the side. I do it all the time. So the answer is 760, okay? So Rupert's going to have number of trees equals 760 after 30 days. Okay, so after 30 days, the answer is 760 trees. This is like a multi-part problem, which is worth a lot, and you're going to see this on your midterm. Thank you, hello. All right. When will the forest have exactly 1,100 trees? Well, we can do this algebraically. So why don't we do this algebraically here? Number of trees, we want to change that now. We want to say, hey, the number of trees is going to be 1,000. So we put 1,000 equals 17x plus 250. Okay, so can we solve this? Yeah, we can solve it algebraically. Just subtract 250. Subtract 250. Okay, so we're left with 17x equals 750. Divide by 17. Divide by 17. So 750 divided by 17, that will give us the number of days. So here we go. 750 divided by 17 equals 44.117. Okay, guys, we got a little problem because that's a decimal. Okay, we wanted an exact number of trees. So, oh, you know what? I read the problem wrong. It doesn't say 1,000, it says exactly 1,100 trees. Hello. Okay, that's 1,100 trees. So that's not going to be 750. Okay, that's going to be 850 divided by 17. Sorry about that. Excuse me. Thank you for your patience. Okay, divided by 17 equals 50. So x is a nice even 50 days. So the answer is 50 days. We just had some fun, and guess what? We solved the problem as well. We solved a bunch of problems. And wow, we had a lot of fun. I hope you had fun. I don't think I did it in the time limit though. So I hope the whole video is gonna fit. I needed 15 minutes and I think I went a little over. But that's our lesson for today. And I wanna show you next how to do this with technology using the TI-84 calculator, and I'll show that on the projector. Okay, that should be a quick lesson, but let's go to that next.